Hello, everyone. I'm Wenli Zhang from Institute of Computing Technology, Chinese Academy of Sciences. Our group recently focused on the research of a network stack for high concurrency and low tail latency. We acknowledge Professor Jianfeng Zhang and OpenCS 2022 committee for providing us the opportunity to introduce our work. Today, I will talk about our high concurrency TCP network stack, QStack, and three related test tools. Hope our open source work can help for the exploration of tens of millions of concurrency. This talk is planned mainly for those people interested in high concurrency network services such as C10M. In this talk, I will give a brief overview first, then introduce the QStack and three test tools separately. The problem we are trying to solve is how to enable a mainstream commercial server to handle 10 millions of concurrent connections, which is called C10M problem. The common understanding of industry and academia on C10M is that in theory, the hardware is not the problem, while in software, the kernel is the problem, not the solution. Then this becomes the research breakthrough and hotspot to C10M, especially with the Internet of Everything era coming. It is predicted that 80 billion intelligent devices will be connected to the Internet by 2025. The demand for high concurrency services will increase rapidly. Have you ever thought that? How many servers are needed to support 10 million concurrent connections and how to test? Do you want to manage a large-scale servers or a few servers? The premise is that we can obtain C10M support in one commercial server. While in a typical LT scenario, the Linux TCP and user space TCP face the dilemma between high concurrency and low tail latency. The mainstream commercial server only can support between 1 million clients within user experience threshold. The gap between 1 million and 10 million urges us to think after user space what else to do for TCP. Emerging application scenarios raise new problems and requirements. Each client establishes a long-lived TCP connection. The server maintains millions of TCP connections at the same time. Each client sends a request in random. At the server, the requests arrival in burst. And user requests are of different processing priorities. The server measures concurrency and tail latency. For these new demands and new problems, we design high concurrency TCP QStack and three tested tools: MCC, high concurrency workload generator, light shaper, a traffic shaper between client and server as an emotional auxiliary to the generator, HC monitor, a full traffic monitor. These four tools are all capable of C10M and C10M test. Also, we propose an abstract C10M benchmark MCC bench and a test case MCC bench IoT and complete C10M tests in one server and 100 millions of concurrency tests in multiple servers. Since time is limited, I won't talk them in this talk. If you're interested, please refer to the paper bench 2022. I will focus on these four tools. As this architecture shown, the above-mentioned four tools can work together to test a high concurrency. They also can be used separately with other tools. The only problem is that when they work with other tools, some functions or performance like concurrency would be compromised. By evaluation, QStack and three test tools are able to support 10 million concurrency in a mainstream commercial server within tail latency threshold in a typical IoT operation scenario, and get an order of magnitude improvement than user space network stack MTCP and Linux kernel TCP stack. Now I will introduce high concurrency TCP stack QStack. QStack enables full data path zero copy and full stack log free to reduce single request processing overhead, application definable full data path priority to prioritize latency critical request processing and support elastic framework to adjust the CPU resources used by stack adaptively. Compared with Linux TCP mainly used in industry and MTCP, the representative user space TCP stack in academia, QStack designs some advanced features including C10M communication and log-free, zero copy, priority in packet granularity, low overhead active yield, and CPU resources for stack adaptively. To evaluate QStack main features, we configure request process in prototype system based on QStack. Use MCC to generate burst or type mixed load, Light Shaper to enhance the quality of traffic and burst, HC monitor to measure concurrency and tail latency. The goal is to test the QStack features. Is the request priority schedule effective? Can CPU resources used by stack be adjusted adaptively? Can QStack get high concurrency and low tail latency in real application scenario? The tests show that the earlier the priority is identified, the more obvious the advantage is. And collaborate with elastic framework, priority defluence shows the actual advantages. This test shows that QStack achieves elastic scalability efficiently. It can successfully adjust the CPU resources used by stack adaptively in 2 statistical periods. QStack is able to support 10 million concurrency and get an order of magnitude improvement I have mentioned earlier. In summary, QStack is a user space TCP/IP network stack that enables high concurrency up to 10 million in one server with good user experience. If you're interested, you are welcome to refer to our paper, and the source code is open for access. Then I will introduce 3 test tools. First is the high concurrency load generator MCC. MCC is a distributed load generator to simulate massive clients. It is capable of generating 10 million concurrency network load in a single server and scalable in multi-core and multi-server. And it has passed the C10M test in 1 commercial server. It is developed based on lightweight user level stack MTCP and support packet content customization, burst traffic generation. Well, although most of the time software-based load generators are generally simple and flexible, most common load generators are in low precision and scalability. MCC improves them obviously. MCC successfully simulates burst traffic. The weight of aggregate load generated by multiple nodes is controllable and repeatable here in within 100 microseconds. So that's MCC. It is also open source. Then I will introduce the traffic transformation tool Light Shaper. To solve traffic accuracy and synchronization problems from the load generator, our goal is to design a pure software network traffic transformation tool based on DPDK, using it to do waveform shaping, speed control, multi-source synchronization, and simulating one traffic characteristics For example, after for order, high latency and packet drop for network load. LightShaper decouples flow characteristic management from load generator and fills placeholder packet to get microsecond accuracy in packet interval control. It gets expected traffic in low cost and avoid multiple level complex modification of load generator. LightShaper successfully gets speed control and flow shaping with microsecond accuracy and successfully obtained the expected distribution. In summary, LightShaper is a pure software network traffic transformation tool in low cost based on DPDK as an optional auxiliary to the network load generator. The source code is open for access. At last, I will introduce the full traffic monitor, HC monitor. The traditional tools like perf and WRK tend to sample the traffic and calculate the request response latency in client. This client-side latency inevitably accounts for unnecessary parts such as kernel overhead and queuing delay. The latency of a request input and output the server is exactly the real overhead, which is called the server-side latency. By test, when the traffic increased to 1.2 million RPS, the latency gap between the client-side latency and the server-side latency would account up to 87%. So our goal is to improve monitor accuracy to get full traffic and compute per request latency to measure server-side latency. Fitting the challenges on concurrency and accuracy, we design HC monitor. It is transparent to network services through switch mirror, capture full traffic based on DPDK, get server-side latency from request input to response output, and show analysis results in real time. HC Monitor has successfully supported QStack and MCC for C10M test. In summary, HC Monitor is a full traffic monitor system that enables high concurrency up to 10 million TCP concurrent connections. If you're interested, you are also welcome to refer to our paper, and the source code is open for access. In conclusion, QStack and 3 test tools mentioned in this talk are all open source in GitHub. Welcome to access and comment. If you are doing some experiments and unsatisfied with your input load, you are recommended to try LightShaper first, while no need to modify the load generator. We have complete 10 million concurrent connection test case. The future will keep updating and bring more function and tools like support HTTPS high concurrency, support efficient processing under Docker. That's all. Thank you. Thank OpenCS again. Welcome to comment. We are sincerely invite people interested in C10M or our work to communicate, study, and work together.